Hello, we are Jimmy, Paul, and Gerald, and we're going to take you through how we did the Kubernetes Hackathon. Yeah, so for starters, the first section was talking about how we can set the core bits, the core bits and bobs of the hackathon. Uh, so we had to create the products DB, the products API, and the stock API, and the web interface. So all of these were some of the different uh, uh, pods that we created, and we had to make sure that all the pods were running. And for that, we can see from yeah this uh, uh, command that I did kubectl, yeah, get pods. You can see that we have the products API, the products DB, the two instances of them, and the stocks API and the web front end. So, so after the deployment, I validated that both the pod, the status, and the tested, and I tested the app endpoint, as you can see from this. So the endpoint that we are using at the end is uh, port 8081, as you can see. And as I will share in due course, we'll see how that has translated. So this is how uh, this is how the application looks like at the moment. As you can see, uh, we have rooted it using the ingress uh, method. So right now we're using widgetario.local, which uh, sorry, as you can see, this is the application, live application that is running at the moment. It's on port 8081, and you can see it is widgetario.local. Yeah. So we also corrected the web to backend configuration so the front end could call the API successfully. So for section 2, which was the configuration, cleanup, and stability, uh, we we standardized the naming and the wiring and the configuration keys. That and we made sure that they're all consistent. So that when we reapply other manifest, they can work without errors. Yeah. So yeah. So uh, also for 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 section 3, which was about the so for section 3, which was about stateful storage and the database topology, uh, it, it offered the biggest architectural change because we replaced the old products DB, the deployment and stateful state to support the stateful behavior. And I created a headless service for the database called DNS resolution, and I added I added the persistent volume and claim templates for the storage. So that I did in, yeah, this part. So here I configured the replicated database credentials using the required environment variables, postgre password and the pg password, as I had shown from this file, vegetarial secret YAML file. And I also then I wired now this API data paths so that the products API reads from both products DB0, which is the primary one, as I showed from from this section, and the stocks API, which reads from products DB1 as the secondary one. So I also added a cache bottom. Yeah, I also added a cache to preserve the sorry, I added the cache route to preserve the cache behavior across the container resource within the pod lifecycle. So after rollout, I verified that both the stateful DB pods were healthy. They returned the success message 200, as you can see. Yeah. So when I call localhost 8081, which is where the main application is, you see that it is successful and it returns the web page. Yeah, thank you. Gerald will take us through the next bits.
I'm going to be talking about parts 4 and 5. Part 4 involved us having to to create ingress in this application of ours. The so the app is only reachable through port 8081 through the load balancer, but we wanted to put this now to a real DNS on standard HTTP ports instead. So we, because we are using Kind, which is like a version of this, it doesn't ship with any default ingress. So we installed Nginx ingress controller inside it. And this is the actual ingress object we wrote. We have only two rules. The first one is vegetario.local, which routes to our web service on port 8081. And then the second one is api.vegetario.local, which routes to products API on port 80. The way this works is that it's through host-based routing. The controller will look at the host header on the request, and then it decides which backend it will send the request to based on that. And then after that, it's simply just now adding a couple of lines to /etc/hosts, and then mapping both domains to localhost, since we're only doing this locally and this already running locally. For part 5, we are supposed now to productionize this application of ours, like making them actually production get, like introducing probes, resource limits, and some security hardening. You can go to Vegetario part 3. Yeah, scroll to the top. So starting with like, I think products.db, yeah. Starting with like products.db, it uses Postgres, and Postgres doesn't really use normal HTTP. So we implemented an exec probe, which it allows Kubernetes to run a command inside the container and check the exit code. And then scroll down. Till we reach products API. yeah, over here. So in products API, uh, we printed the probat slash actuator slash health, which is the standard for Spring Boot applications. But it kept crashing out. It kept crashing. It kept crashing. But we eventually found out because it was because JVM would be taking a long time to boot, like 28 seconds, and it would bring around about 4 fours. So we switched, and we switched the probe path to something else, to slash actuator slash Prometheus, and then this would bump the initial delay up to 45 and 60 seconds and increase the timeout. By the time it would get to the probe, the JVM application would already have booted. Then resource requests and limits to set a scheduler to sorry. Then we implemented resource requests and limits to set a flow for the scheduler to guarantee that when placing a pod, it doesn't exceed like the memory limits, and it kills that process instead of like ballooning your application and making it slow. You can scroll down a bit. Yeah, these are our resource requests. We are setting our CPU to 250 and then our memory to 512 megabits. And for the last thing that we are supposed to do to productionize it, we are supposed to harden it, like making it more secure. We scroll to, yeah, this is probably what we set allow privilege escalation to false for every container to stop the process gaining more privileges than it started with, because initially it wasn't like that. Uh, we we did try to go further and implement run as non-root, but this would end up breaking every single container since none of these images have had any non-root users configured. They all defaulted to root. This was just how the lab was set up. So rather than rebuild the images ourselves, we just removed that whole line and documented it in our README.